All right, guys, let's take a look here. All right. Who's got this one here? Yeah, so as the inputs approach -4, the outputs look to be going towards 2. Then, of course, as it approaches -4 from the right, I look at the inputs going towards -4. The outputs look to be going towards 2 again. Okay, so those two should have been nice. Do they agree?
Yep.
Yes, so then I can say here, generally, what's the limit as x goes to -4? It's 2, because there is agreement. There is a thing there, it's approaching, period. I like it. Guys. And then, what is this, though?
Undefined.
Undefined. Why are you writing the whole word? I don't know. You almost did. Okay. Oh, there you go. Undefined. All right. No. All right, I like it, you guys. So it's really weird. You got to really tell yourself the limit does not care what is happening at that point. It doesn't care. It's not even that it doesn't care. It doesn't get there. It doesn't know. What about this one? Going towards 1 from the left. So as I approach 1 from the left, the outputs look to be approaching 4. As I approach 1 from the right, the outputs look to be approaching -2. I like it. Please let me know if you have questions. So can I say there's a general limit at 1? No, they don't agree. There is no general limit at 1. But f of 1 is what? 4. F of 1 is 4, because that's where it's filled in. And then going to 6 from below, it approaches 5. Oh shit, I can't show you everything at once. 5. Going to 6 from above, of course, it goes to 5. And so going to 6, it is 5. But what's f of 6? Freaking 2. All right, I like it. It looks like it's going to 5, and then it's a 2. Oh shit. All right, I like it. I like it. Okay. What about number 2? Did anybody get number 2? I'm going to have to steal my calculator back.
Oh, yes, please do. I was just about to get to it. Thank you so much.
All right. Let me show you something really cool. Really, really cool. I'm just going to show you this. Watch what I'm going to do. So I'm going to put into y equals. I'm going to put the function I'm dealing with. Tangent. I'm going to make sure that I'm in radians. Oh, I'm not. Okay. A little personal story from just past. I had a teacher who was really evil. Normally you could tell if you have it in the wrong mode because you get like really insane answers. But if a teacher really wants to, they can design a quiz that the answer is good either way. And that's what this one teacher did to us. I had my calculator in the wrong mode. Got a complete F on that thing, right? So just learn from my mistake. I always hit that mode because you're going to see some degree questions in the book. You're going to see some radian questions. If you always want to be in radians, you can just make degrees into radians and then you're golden. So now I'm in radians, thank the Lord. Then I put in here tangent x minus pi. You don't have to have done it this way, by the way. I just want to show you something kind of nifty. Divided by x minus pi. Do you guys know about the table? Right? So if I go to table, how do I have it set up right now? Okay, so let me show you something kind of nifty. Under table set, do you see where it says ask? Have you ever noticed that? Have you ever had a teacher tell you about this? Now when I go to table, it's blank. And then I could just put in whatever I want to, 3.1. Bam. So I can just basically make this table in my calculator. Is this neat to anybody, or do you guys all know about this? Yeah, this one's kind of boring. I didn't make a very good problem. I'm sorry. Yes?
Should I bring my graphing calculator?
Yes. Well, like I said, on the quiz day or test day, I assume everybody's going to have a calculator, but just in case yours dies or in case you forgot it, I'll have a little bag of calculators. Yeah, this is kind of boring. I don't know why I made this problem. It's really easy to tell what the limit is.
Not the first one.
Sorry?
Not the first one.
Yeah, the first one was kind of neat. It's 1.006. And why is that 1.006? Because I'm not very close to the input that I want, right? And then I'm getting closer to the input that I want. Yes?
How did you get there from y equals, like on the calculator?
Oh, so here's I put the function in, right?
Yeah.
And then I went to table set. Table set, and I changed this to ask. And it does exactly what it sounds like. It's going to leave this all blank, and it's going to ask you, what do you want the input to be? I don't think can it go the other way around? Let me see. No, it can't. Okay. Oh, it's yours. Okay, I like it. I like it. Yes?
Do you know why I got the wrong answer if I did it like the long way, like not that way?
What'd you get?
0.017, and then so did she.
A couple of things. Actually, I've got your work here, I think. Let me not put it up here for everybody. Let me see what you did. Jeff.
So you said you got 0.017?
Yeah.
Do you have your calculator in the wrong mode? Because I got the same thing, so I changed it.
Was it in radian?
Oh, yeah, I had to change mine to radians, didn't I? So
Oh,
you had
it
it in
was in
degrees.
degrees.
You had it
Okay,
in
that's
degrees.
why
Okay,
then.
okay.
You just changed it? Okay.
That's the
Okay,
that's
that
the
makes
easy
sense.
answer, yeah. So normally, if Jeff would have been a little bit better at this job, he would have made a problem where, like if I wanted to know the limit as x goes to 1 of some function, right? You could make a table going 0.9, 0.99, 0.999, 1.001, 1.01, 1.1, approaching 1 from both sides, the same way we did when we're thinking about limits graphically, right? And then if this is a 2.17, 2.11, 2.10, and this is 2.10, 2.11, 2.17, then I would say that my guess would be 2.1. And I might have to make this even, more detailed if I want to see really. Are you guys semi with me? You guys with me now? Okay, so you're going to see problems exactly like this. You can construct them in your calculator, and now you know how to make the table in your calculator, which is really kick-ass. So you don't have to do each one individually. All right. So what about down here? Hopefully that first one was not a big problem. It's obvious what I need to do here, right? Well, what's the first thing you did? Sorry?
Sorry, I was going to ask if you can turn on the AC because I'm freezing.
Oh, I'm sorry. Yeah. Please let me know if it gets too crazy.
Thank you.
Get out of there. No. All right. It won't let me change it. Holy shit. Oh, there it is. Okay. Thank God. That was freaky. All right. It's like, no human too bad. I'm always going to run warm. So you got to, let me know. It's no big deal. I can control that one. This one doesn't work for some reason. There's another one back there. So this guy does the whole room. So that's why. Okay. So what's the very first thing I should do on this problem? Plug 3 in. See if there's a problem. And there's a problem, right? You get 0 over 0. Indeterminate. I love that name because you can't determine what the answer is. So you need some help. So obviously, what do you do? Factor. So you get 4 out, x squared minus 9. I'm just going to kind of cut to the chase here. Is that cool with everybody? And this is such a beautiful idea. I can't plug 3 in, and it's because now I can see why. That was the problem. Well, there's your problem right there, right? And now I can plug a freaking 3 in. And then what do you get? 24. So it's just so direct. I love that. It's just so direct. Here's the problem. Kill it. No problem. I like it. Don't do that in real life, by the way. Don't just kill your problems, please. All right. These are not life lessons. These are calculus lessons. All right. Now this guy you should have been ready for. Right? What do you have to do here? And of course, you plug a 0 in. It's indeterminate, right? So you have to do something. What am I going to do? Gotcha. Or 3 plus square root of x plus 9. So I get the limit as x goes to 0. And yes, I'm trying to model good behavior. You keep writing the limit until you actually apply it, or else you're lying to me with your work. Okay. So on the bottom, I just get 2x times this mess. What do I get on the top?
Negative x.
Yeah, I get 9 minus x minus 9. Now, one big thing people forget, what's wrong if I do this? What have I done? Oh, shit, I'm so zoomed in, guys. You can tell me. What have I done wrong? I've done something wrong. Yes.
Did you have to put the x plus 9 in parentheses?
Yes.
To get the negative?
Minus this whole thing. Bam.
Okay, cool.
So I get the limit as x goes to 0 of x over 2x times 3. Oh, God, Jeff. All right. The x is, so here, again, this is so beautiful. There's your problem, right?
It's a negative x in the numerator.
Is it? Oh, yeah, thank you. There's my problem. And then you end up with, when you plug it, now I can plug a 0 in, right? What do you get? Negative 1 over 12? Is that cool? Okay, I like it.
Would you do on the second part? So see where you have 9 minus
Yeah.
x. Would you want for that?
Oh, 9 minus 9 is 0, and then everybody help me out. Negative times x is negative x. Yeah. Okay. Now, see. Oh, sorry. Everybody cool? What's up?
Sorry, I'm trying to simplify so I can read this later.
Oh, okay. Yes.
Oh, never mind. Got it.
If you... Oh, never mind. I got it.
Okay.
My bad.
That's all right. Okay, now, I've given myself no room for this last one, so here we go.
Oh, me.
What the hell do I do with this? I kind of helped a few people out with this one. Yes?
This might be a stupid question. Can you, whenever my brain sees that, can you flip and multiply?
If, so you could.
Okay.
Are you thinking about when you divide, you multiply by the reciprocal?
Yeah.
Okay. Totally. But that actually doesn't give me shit.
Okay.
So watch. If I do that, I'll get 1 over 2x minus 1 over 4 times 1 over 2x minus 4. That doesn't do, that's a times, by the way. That really doesn't do anything for me, right? It doesn't. It just doesn't. Okay. It would make sense to do that. What do I do with this? What would I do here? Let me make a problem up. Hold on, everybody. What do you got, Jeff? I don't know, man. There we go. Okay. What would I do with that problem?
Multiply it by 5.
Yeah, I like it, but or you could just do 3/5 times 15/2, which is what you wanted to do, right? And why does it make sense here? Why does that actually lead to something good? Because there's only one fraction in the top and the bottom.
Yeah.
So your thought process doesn't work immediately, but then you realize, can I make this one fraction? Then I can do that. How do you make the top one fraction? This is not the only way to do this, by the way. But how do I make the top one fraction? I have to get LCD right. You guys with? So I got to multiply the first one by 2 to get a 4 on the bottom. I have to multiply the second one by x to get an x on the bottom. Is that all right, guys? Did I skip too many steps there? Are you guys with me?
A little bit.
So if I multiply this one by 2
Oh.
and multiply this one by x, they both have a 4x on the bottom, right? Now what have I left out? Oh, good, nothing. Now I can do, now again, I'm kind of doing more than I normally would, but let me show you. Now I can do this, which is kind of, well, it works, it's fine. At least you don't have a fracception, right? A fraction inside of a fraction. So what works nice here? Anything kind of want to die here? Existence is pain. Huh? Yeah, factor the 2x minus 4. And then these will cancel, but they'll leave what? A negative 1. Are you guys at all with me? Right? If I take a negative 1 out of this, x becomes positive, 2 becomes negative. So these cancel, leaving it with a negative 1. Okay. So let me continue here. So then I get the limit as x goes to 2 of negative 1 over 8x. Leave no man behind, right? 4x times 2, 8x. Negative 1 times 1, negative 1. And of course that is just negative 1 over 16. What the shit? Okay. Real quick, did somebody do that a different way? Anybody? Nobody?
I didn't have enough time to get to it.
Oh, I'm sorry.
Yeah, me either.
All right. Well, you should know that about me, and I'm an asshole. Yes.
Yeah, see, go for it. Second. Okay.
Let me zoom out a little bit. Okay, maybe. So you look for that radical kind of expressions, conjugate. You think conjugate. Fractions inside of fractions, you think combine and multiply by the reciprocal. The other way to do that problem, by the way, and then I'll let us out of here. Somebody got that? No? It's really weird, huh? Okay, I understand. Let me see. Real quick, let me do this, and then I'll write it better. If you were to multiply top and bottom by, what is it, Jeff? 4x. Doesn't that clear the fractions in the top? 4x over 2x is 2. 4x divided by 4 is x. You guys see that? And then I factor this. It's basically the same math, just kind of reorganized, right? So that would work also. The whole problem is there's too many damn fractions. The number of fractions is too damn high. So we have to kill some of them somehow. Okay, I like it. So real quick, for, oh shit, what is that? I've run out of my papers. Yeah, good job, Jeff. Yeah, I've run out of all my papers. Well, you and me can talk about this after class, I think. I think that's enough. What do you guys think? Is that enough? Did I remember to turn this on? Yes, I did. Thank God. So I will post